This is 9.2, dealing with absolute values. So the absolute value of x equals 3 is asking what values for x have a distance from 0 of 3. So can you think of any numbers that are 3 units away from 0? Well, the number 3 and the number -3. So that one's pretty easy. What if I had x plus 2, take the absolute value, is equal to 5? Can you think of any number that you can add 2 to and get a distance that is 5 units from 0? So I want to end here and here. So are there any numbers that I can add 2 to and get 5? Well, one of them would be 3, because 3 plus 2 is 5, and the absolute value of 5 is 5. What would the other one be? -7. So -7 plus 2 is -5. And if we take the absolute value of that, we get 5. Okay, so that's a little bit harder. What about 2x minus 6 is equal to 4? That gets a little bit harder, and we could work it out. But there has to be an algebraic way to solve these. And the answer is, once you have the absolute value isolated, then you split it into two equations. So once you get this piece by itself, then you can split it into x is equal to 3, or x is equal to -3. And the same thing works here. We're going to split this into x plus 2 is equal to 5, and x plus 2 is equal to -5. And then subtract 2, x equals 3, subtract 2, x equals -7. Okay, so if we split this, 2x minus 6 equals 4, and 2x minus 6 equals -4. Add the 6 to get a 10, and divide by 2 is 5. Add the 6 to get a 2, divide by 2 is 1. So apparently, if I take 1 and 5 and plug them into the equation, I will get 4 in both cases. So let's check. So if I start with a 1, 1 times 2 is 2. Now I'm there. Minus 6, 1, 2, 3, 4, 5, 6. Is this number 4 units away from 0? Yeah, it worked. Let's try 5. So we'll start with 5. 5 times 2 is 10. 10 minus 6 is 4, and that is 4 units away. Now, you do have to be a little bit careful. Let's say I had 2x minus 8 plus 4 is equal to 12. You are not allowed to split until this is all by itself. So I need to subtract 4, and I have the absolute value of 2x minus 8 is equal to 8. Let's say there was a 2 out here as well. I still can't split because the absolute value is not by itself. So we divide by 2, and I get the absolute value of 2x minus 8 is equal to 4. Now we split. 2x minus 8 equals 4, and 2x minus 8 equals -4. Add the 8 to get 12, divide by 2, x is 6. Add the 8 to get 4, divided by 2, x is 2. So the absolute value has to be by itself in order to do the split. Also, there's another problem. What if I had this? Why? When is the distance from 0 equal to -3? Never. Distance is always positive. So that is an equation without a solution. Okay, what about this? That does have a solution, because if you add the 6 to the other side, now the absolute value equals a positive number. All right, what about this? That has no solution. And the tricky thing about this is, if you solve it, it will give you an answer. So if I subtract 4 and I get this, and I don't realize that it's no solution, so I split, x plus 1 equals -1, and x plus 1 equals 1. Add 1 and I get x equals 0. Subtract 1 and I get, subtract 1. I did that wrong. That should be -2, and this should be 0. So if you don't realize that it's no solution and you go ahead and solve it, you're going to get two answers. But notice, these answers don't work. -2 plus 1 is -1. The absolute value of -1 is 1. Is 1 plus 4 equal to 3? No. If I try 0, 0 plus 1 is 1. The absolute value of 1 is 1, plus 4 is not equal to 3. So you do have to be a little bit careful. You need to make sure that you don't have an absolute value equal to a negative number. Okay, so that does a whole bunch of these problems. That's that one, and that one, and that one. Okay, what about an absolute value inequality? Well, first we need to ask, can an absolute value be greater than or equal to 3? Yes, it can. So we do our split just like we did before. X plus 7 is greater than or equal to 3. The trick is, when you do the negative, the inequality has to flip. So x plus 7 is less than or equal to -3. So we solve. So subtract 7. X is greater than or equal to -4. Subtract 7. X is less than or equal to -10. So on our number line, we have a closed circle at -4 going up, and a closed circle at -10 going down. Okay. All right. What if it said greater than 5? So we split. X plus 7 is greater than 5, and x plus 7 is less than -5. So we subtract 7. X is greater than -2. We subtract 7. X is less than -12. Did I do this wrong? Oh, I did. Whatever. That's not what I wanted to do. So -12 and down, and -2 and up. Okay. Let's do what I meant to do. Okay, what if it said less than or, well, let's say we have x plus 7 minus 3 is less than 12. Maybe let's not do 12. Let's do 4. Okay, so we add 3. The absolute value of x plus 7 is less than 7. Now I split. X plus 7 is less than 7, and x plus 7 is greater than -7. So we subtract 7. x is less than 0. We subtract 7. X is greater than negative 14. So this one has a negative 14 and up, as well as a 0 and down. So it's just going to be everything in between those two. And if you wanted to write them as a single compound inequality, you could say negative 14 is less than x, which is less than 0. You can only use a compound inequality when the arrows are going together. If the arrows are going apart, compound inequalities don't make sense. So, for instance, if x is less than 4 and x is greater than 6, so here's 4 and here's 6, a compound inequality doesn't work. You would say 4 is greater than x, which is greater than 6. And you can see there, that's impossible. There's no way to be smaller than 4 and bigger than 6 at the same time. So you're only allowed to do compound inequalities when the arrows are going towards each other. How do we solve two inequalities that are equal to each other? Well, obviously, 4u minus 5 has to be equal to 4u minus 2. Right? Oh, well, this one's dumb. I don't know why they would set this up this way. So if we add 5 and subtract 4u. Oh, thank you. Not going to change the outcome, but you're right. So here I get 0 equals negative 7. When does 0 equal negative 7? Never. So this one has no solution. Okay. Okay, but here is the rule that we're going to look at. In order for two inequalities to be equal, either the inside of the first one is equal to the inside of the second one, or the inside of the first one is equal to the opposite of the inside of the second one. So when we set up that first inequality, this doesn't work. 4u plus 5 cannot equal 4u minus 2. However, when we set up the second half, and we say 4u plus 5 is equal to the opposite of 4u minus 2, then we distribute the negative, we move the 4u to that side, and we move the 5 to that side, and we end up with u equals negative 3/8. So let's do another one. Oh, this is the same thing. Anyway, 2y plus 6 is equal to 2y plus 3. Hopefully you can just look at that and say that's impossible. Can we take some value and add 6 to it and set that equal to the same value and add 3 to it? No. So that piece of it falls apart. The other piece, 2y plus 6 is equal to the opposite of 2y plus 3. Distribute the negative. So we add 2y. 4y equals negative 9. So y equals negative 9 over 4. That's the only solution. Okay, that is everything. Get to work. Most of you are mostly or partially done with this anyway.